Hi students, welcome again to our YouTube channel. So in the last video we did one problem regarding the calorimetry, in which we found that the initial temperature of the iron sample by using Q is equal to mc del T. Okay, so that solution is already present in our last video, so you can check from here. Okay, now today we are going to solve another example of like such basic calorimetry problem. And the problem says that a 58.7 grams of brass is put into a calorimeter that contains 200 grams of water. The brass sample starts off at 91.0 degrees Celsius, so it means that is the initial temperature of the metal, and the temperature of the water starts at of 21 degrees Celsius, so it means the initial temperature of the water is 21.0 degrees Celsius. When the temperature of the water stops changing, its final temperature, that is 22.8, the pressure remains constant. So now you have to calculate the specific heat capacity of the brass according to this experiment. Be sure your answer is rounded to two significant digits. So first of all, here we have to use that the heat capacity equation to solve this problem. Here I am going to write heat capacity equation. Okay, according to that will equal to del E is equal to m dot C dot del T. Okay, like mass times specific heat constant times change in temperature, or in other word you can say that Q is equal to mc del T. Okay, now first of all you can see that let's apply the general ideas of the problem you have got. The first one, you know that here you can see the change in the temperature of the water, like you know the change in the temperature of the water, and you also know its mass, that is 200 grams. So it means, and you already know about the specific heat constant for the water that we already did in our last video, that is 4 point, here you can see 184. Okay, so that is already present in the ALEKS data table. And now the next thing, that you can calculate the thermal energy of the water gain from the heat capacity equation. Okay, so it means here the first step you have to find del E for water. Okay, that again equal to m c del T. Here the change in temperature del T is equal to the final temperature is 22.8, so here is 22.8 minus the initial temperature, that is 21, so it means that is 21.0. so here that is equal to 1.8 degree Celsius. Okay, let's suppose you have to say that is your equation 1. Okay, now you have to put the values, and you know that the mass is equal to, here m is equal to 200 grams, while c is equal to 4.184. okay, so you can easily put these values in the equation, then you can got the del E of the water, or you can say the conservation of the energy or the thermal energy of the water gains. Okay, so that will equal to, here I am going to show you with different color, del E of the water is equal to m is equal to 200 grams into like the specific heat constant, that is 4.184, while the temperature is change in temperature, that is 1.8 degrees Celsius. Okay, so now calculate it, and the answer will be del E W is equal to here 1506. Okay, 1506 joules. Now that is your first step, in which you have to find the thermal energy of the water, that is 1506 joules. Okay, now the next step, in the next step, here is the second step. The second step is, like, according to conservation of energy, that equal to the thermal energy of the metal lost, which means that you can also find the del E for the metal. Okay, so it means here you can say here del E of B, that is the metal brass, is equal to del E W, but here that will be negative. Why? Because the energy lost from the metal, that equally energy gained by the water. Okay, here, so it means now the del EB will equal to, that will equal to how much? Is equal to minus del EW. It means that will equal to minus 1506 joules. Alright, so that is the next step. Now you need to find the change in temperature of the metal by using initial and final temperature. Like the final temperature is 22.8 degrees Celsius and the initial temperature is, here you can see, 91.0 degrees Celsius. So it means you can write 22.8 minus 91.0, that will equal to minus 68.2 degree Celsius. Okay, so that is the next step, in which you have to find the change in temperature of the metal. Now as like you know that here del E, that is for metal, is equal to mc del T. So you have to find C here. Okay, let's suppose I am going to show you with different color. So you have to find C here. So it means now you have to rearrange it. So after rearranging, the C will equal to the specific heat constant for the metal is equal to del EB over M into del T. Okay, because mass and the change in temperature is multiplied by C. So when we shift into the other side, it will go into the division form, like it will go into the denominator. So here you have to put the values. So CB is equal to, now the del EB, as we already know, that is 1506 divided by the mass that is already given in the question, that is 58.7. So here you have to write 58.7 times, and the change in temperature, that is equal to minus 68 point, here you can see minus 68.2. So negative 68.2. Okay, so now you have to find it. So that will equal to, like you can see, the negative will cancel out. So it means CB will equal to the specific heat constant for the metal, that will equal to, like, first of all multiply the denominator values 58.7 times 68.2, and then like divide 1500 by the given answer, and you got 0.3762, that is in joule per grams into Celsius. Okay, so that is your answer. It means now here okay, so that is the specific heat constant for the, like you can say, that is for the metal that is used here, that is brass. Okay, now the question is, you can check, be sure your answer is rounded to two significant digits and you have to write in a significant numbers. So it means that will equal to here 3.8 times 10 to power negative 1. Okay, so that is your answer. Is it clear? So that is the way in which we can find the different values and the different entities by using specific like the heat capacity equation for the calorimetry problems. Okay, so that is your answer. I hope you would like our video. If you like it, so kindly subscribe us and share our channel. We'll see you in the next video. Take care. Goodbye.